Hello, everyone. My name is Ranan. This is Gary. We are part of the Babylon core dev team, and we'll be presenting Babylon.js and WebXR. We will go over Babylon and Babylon native, and then we will talk about WebXR in Babylon.js and how we integrated the protocol. We will leave some time for Q&A at the end, so if you have any questions, we'll be happy to answer at the end. So a bit about Babylon.js. Our goal in Babylon.js is to create one of the most powerful, beautiful, simple, and open web rendering engines. Babylon is a fully featured 3D rendering engine. We provide everything a developer needs to create a 3D experience on the web, from model loading, input handling, physics engine, a particle system, different materials and textures. Everything is integrated in the core library. Babylon is a JavaScript library and built on top of open web standards. We do our best to only work with web standards to provide a unified experience across devices and browsers. We use standards like WebGL and its younger brother WebGPU, WebAudio, WebRTC, and WebXR, as we will see later, GLTF for model loading, and a lot of others. Babylon is always backward compatible. Code that you were running on Babylon 3 will still run on Babylon 5. We're not removing features. We're updating them, preserving the public API, and adding, of course, new features to the public API. Babylon is a mature platform. It's roughly 10 years old, and it's being used in production by many different websites, from Target to IKEA to Ferrari's car configurator, but also Microsoft Teams and PowerPoint. They're all using Babylon to enhance their user experience. Babylon is written natively in TypeScript. It's completely free and open source. Everything we do, including our different modules, our website, our documentation page, everything can be found on GitHub and can be used and is open. Another thing that we have open is our public release schedule. We have just released Babylon 5 a few weeks ago. We are currently at Babylon 5.10. We are constantly releasing minor releases, update stable minor releases. And our next version, Babylon 6, the roadmap can be found online on GitHub. Apart from the core library, we provide different tools to improve the developer's experience and help getting started with the framework. The first tool I want to talk about is the Playground. The Playground is a website, a Monaco-based code editor that allows you to experiment with the framework in your browser. You can save the Playground, you can share it, you can download it, you can run it locally, and you can view examples in the Playground with the code curated by the Babylon team. It's a wonderful starting point for your Babylon journey. A bit of code. When visiting the Playground, the first scene you will see is the default scene, and that's the code you can see here. The scene creates a sphere and a ground, and it's here. I'm showing the code just to show the simplicity of the Babylon API. How with a single line of code you can create any of those nodes, from cameras to lights to different meshes. The second tool I want to talk about is the inspector. Here you can see the inspector integrated in our Sandbox. The Sandbox is a website where you can drag and drop models, either online or local, and you can see them right after dragging them. The inspector, which is the two parts you can see on the right and left, is a scene debugging tool, which allows you to see the scene graph, to see all of the nodes, to disable them, enable them, to see their materials, to edit their textures, and a lot more. It's web-based and can be integrated in any Babylon experience, either local or online. The third tool we have is the Node Material Editor, which is a no-code shader creation tool. You can create different shaders using different components and connections between them, and export them as a JSON or save them to our snippet server. This JSON or the snippet that is stored can be added to your scene with a single line of code. And the fourth tool is the UI editor. We offer a UI editor that uses Babylon's UI module. We have a UI module with different UI components, and this tool allows you to edit and create UI for your experience using those different components. And the same thing as the Node Material Editor, you can save it either locally as a JSON file or as a snippet and load it just with a single line of code into your experience. And so far, we talked about web tools and web experiences, but sometimes you need native application and native experience. Gary will talk about Babylon Native.
Thanks, Ron. So, Babylon Native. Babylon Native is a collection of technologies intended to bring the power of Babylon.js to cross-platform applications beyond just the browser. The goal is to allow the reuse of the same JavaScript code that powers applications written in Babylon.js to work identically in native applications. And because we're running the same code, it lowers the development cost and increases consistency across different scenarios. So for example, GLTF rendering. Even the tools that were mentioned earlier by Ronan for the playground and the editors that you saw will be useful because you can prototype in those tools first, get it working on the web, and then just basically copy it over and have it work in the native environment. Furthermore, Babylon Native is about flexibility. We're no longer bound to the confines of a browser. We're free to choose any JS engine you want to use and any UI framework we want. We also try to make the library as flexible as possible so that we can integrate with almost anything. So here's a sort of non-exhaustive view of the runtime. The library consists of three main core parts: the core section you see on the left, plugins in the middle, and polyfills. The core contains a graphics component which uses BGFX. And BGFX is an abstraction layer for OpenGL, Metal, DirectX, and more. And it also hosts the JavaScript runtime, which loads Babylon.js itself, application-specific scripts for your application, or other dependencies. The plugin provides functionality such as the native engine, which is it connects the Babylon.js engine with the graphics component so that it does the rendering. Native XR, which is the module I'm showing on screen here, which provides XR functionality for Babylon.js and relies on the underlying platform technologies. I'm going to talk a little bit more about this in a bit. And finally, we have a few polyfills for common functionality that Babylon depends on. But note that this is not the typical web polyfill. It's a partial polyfill, only enough to be able to support what Babylon.js needs. Okay. And finally, these components are perhaps optional, depending on what your situation is. And they can either be completely omitted or replaced with a custom version if you need to. Okay. This makes it possible for you to integrate with pretty much any existing technology. So one such technology is React Native. So let's talk about that next. We have an integration with this. So. But before we talk about Babylon React Native, in case you haven't heard of React Native before, I'm going to give a quick overview. React Native is created and maintained by Facebook, now Meta, as a native counterpart to the React library, which is used for building UI. It can host the JavaScript engine, for example, JavaScript Core, V8, or Hermes. And features like fast refresh improves iteration time pretty dramatically compared to the typical native development cycle. And lastly, it runs on Android, iOS, which is supported directly by the main repo, as well as Windows and macOS, which is maintained by Microsoft in a separate repo. Okay. So now that we know a little bit about React Native, how does Babylon Native fit with it? So this is where Babylon React Native comes in. We can think of it as the glue between Babylon Native and React Native. It provides a React hook to manage the lifetime of a Babylon Native engine instance, as well as a UI component that provides a rendering surface for Babylon Native to render to. And speaking of flexibility from the previous slide, Babylon Native is configured to hook into the same JavaScript context that React Native provides. And this way, we don't have to create two separate JavaScript contexts. It's actually using the same one. And like before, here's a breakdown of what a React Native application looks like. At the top is the application itself, which relies on two main NPM packages. On the right, you have Babylon.js Core, which is the same package you would use if you were developing for a web application. And on the left is Babylon.js React Native, which is the glue code I was mentioning earlier that will connect Babylon native with React native. And of course, Babylon native then depends on all the things that it depends on. But I do want to call out one thing. The XR part, as I mentioned earlier, relies on the platform-specific libraries. Right? So for Android, it will use ARCore. For iOS, it will use ARKit. And for everything else, it will use OpenXR. Now, OpenXR is growing in the list of platforms that it supports. So eventually, it will make it hopefully to many different places. So we can use OpenXR for those platforms. OK, so next, we will dive into XR a bit more and see how it works under the hood. I'll hand it over back to Ronan to tell you more about the web side of things first. OK?
Thanks, Gary. So before we talk about Babylon.js and WebXR, let's talk about WebXR. What is WebXR? So WebXR is a web standard that defines a set of API to allow immersive web experience in your browser. It comprises of the main WebXR device API and many different extensions or modules that enhance the immersive experience in both VR and AR scenarios. It is currently in draft, and it's constantly changing and improving. WebXR is not directly related to OpenXR. Having an OpenXR implementation in the system does not mean that WebXR is supported there. There are two different standards controlled by two different groups. Though as Gary mentioned before, the underlying implementation of WebXR can and probably uses OpenXR under the hood. WebXR is currently supported in Chromium browsers, so Edge and Chrome and many other Chromium-based browsers on Android, for example. Firefox supports WebXR behind a flag, and Safari sadly does not support WebXR yet. We hope that they will eventually provide WebXR implementations. WebXR has replaced WebVR, which is an old VR protocol, which was VR only and didn't support AR, and now WebXR supports both immersive AR and VR experiences. A bit about Babylon.js and WebXR. Babylon supports the device API fully and many of the available WebXR modules. We support heat testing, we support anchors, plane detection, hand tracking, light estimation, and many different other modules. To keep a familiar environment for WebXR developers, Babylon provides a module for each WebXR component and provides the WebXR object that is being used under the hood, if the developer needs that. It's recommended to use the Babylon abstraction because Babylon creates a public API to help you integrate with WebXR. The best example for that is the right-handed system versus left-handed system. WebXR is natively right-handed system, and Babylon is left-handed system. Under the hood, when using the Babylon components, Babylon converts right-handed system to left-handed system automatically for you, so you don't need to do this conversion yourself. And when using a Babylon.js component instead of a WebXR component, you can use Babylon's engine's full features in your experience, in your XR session. Babylon introduced the WebXR Experience Helper. It's a way to start with a single line of code, a VR or AR experience. It's fully configurable. It includes a WebXR camera, input and controller support, pointer emulation for WebXR, teleportation, enter and exit button, everything you need to start an XR session on the web. The two examples we can see are, the first example is how to start a VR session with really a single line of code. So calling the create default XR experience function with no configuration options whatsoever will start the default experience, which is a VR-based experience with everything I mentioned before already enabled for you. The second example is how to start an AR experience. So the difference between AR and VR in that case is just stating that we want an AR experience, and a supporting device will simply start the session correctly. If the devices are not supported, then the enter and exit button will not be shown, and Babylon will provide you a way to react to the user. As I mentioned earlier, there are different WebXR modules that are in draft mode and are constantly changing, improving. Their public API changes as well. And in order to provide a smooth and transparent update of those modules across browsers and in browsers that have different specs, in different versions, we introduced the feature manager. Think about the features manager as a plugin system with versioning that allows you to load a specific WebXR module in a specific version to a specific browser. So you're still loading the hit test module, for example. The public API that you're going to use, the Babylon API, still stays the same, but the WebXR implementation under the hood updates for you. Let's see a few demos. All of those demos are running in your browser. The first demo I want to show is the Mrtk for Babylon.js. Mrtk is a set of UI tools that can be used to enhance your XR session. It works on desktops and VR and AR experiences. It supports both controllers and near interactions, which means that if you enable the hand support, for example, on the HoloLens or in the Oculus browser, you can actually interact with the components with your hands. So you can press the buttons, you can pull, you can drag, and this is fully supported by Babylon.js. We support many components, the near menu, the hand menu, different styles of buttons. We have sliders, and we have gizmos, modal gizmos or node gizmos that allow you to transform the node as you wish and rotate and translate it. The second demo I want to show is the physics playground. It's a VR experience, in this case running on the Oculus Quest, which has a full physics support for everything in the experience, including your controllers and your headset. So using your controllers and practically your head, you can interact with everything in the scene. You can pick objects, you can push the objects, and this scene also supports hand tracking. So using hands, you can also interact, even pick, if possible, objects, and the hand has 25 physics imposters that allow you to really interact, even with the fingers, with everything in the scene. An AR example, talk a bit about hit test and light estimation. Hit testing, think about hit testing as a ray coming from your device towards the plane the device is pointed at. The hit testing module provide a transformation point on this plane, which allows us to place an object on top of this plane and make it as realistic as possible, and when placed on the correct plane in the correct transformation. The second module that is enabled in this demo is the light estimation, which provides a realistic light reproduction, including the light color, the light direction, where the light is coming from, which allows us to place shadows on these elements, and also provides an environment map and a realistic environment reflection map that allows us to create reflections on shiny objects like the sphere we see here, which creates a more immersive experience. The fourth demo is a live demo I want to show you. It's an image tracking demo. If you want to experience with that, you can scan the QR. You can use the QRs at the edge of your seat. It works on Chrome for Android. And since the market tracking is still unstable, you need to enable the incubation flag on Chrome flags. So if you want to experiment with that, you have an Android phone, you first need to go to the Chrome flags page, enable WebXR incubation, scan the QR code, and you will see the playground. And I will show you exactly what you're about to see. So it's called WebXR incubation. I'm sorry? No iOS, sorry, yes. As iOS does not support WebXR yet, very sadly, it does not work on iOS, but we will see later how we can get iOS support with Babylon native. So when you open the playground, that's the code that you will see, and that's the demo. So if you enter the XR session, which is the small button on the bottom right of your screen, if you scan the QR code, there will be an object placed on it. In that case, a running fan. Sadly, it doesn't produce any wind. And the code that is running it can be seen here to the left. The first part of the playground is really just the preparation, loading the model, setting its animations. This is not XR related. This you will do in any other experience you're making. The XR code that is running this specific example are those 20 lines of code roughly. So the first line of code is, as I mentioned before, entering and preparing your session. Preparing your session. The first line, the create default XR experience, gives us the enter button that allows us to enter the session. Afterwards, the feature manager. And the feature manager in this case is being used to enable the image tracking feature. And the image tracking feature takes a list of images that can be tracked in this specific session. The image tracking feature also provides us with callbacks on everything that happens with those images. Now, this is a Babylon public API. This is not the API of the WebXR marker tracking module. It's based on observables, and it provides us an observable for when an image was detected, when an image was removed, and then when an image was updated. The image updated usually fires every frame that the marker is in frame, which means we get a new transformation on every frame. And using this transformation, we provide the root node a new transformation on each frame, which allows us to experience as if the object is right on the image, on the tracker in that case. I'll let you experiment with that a little bit, and we can continue in a second.
If people are done, okay. Okay, so let's talk about how XR would work in Babylon native. Okay. But before we actually start there, let's talk about why you might be wondering why we wouldn't just use a web view to do this. Okay. There are a few reasons. First is, if you're using WebView, WebXR is actually not supported in both Android and Apple web views right now. On Apple, it's not even supported in the browser. Right. And second, WebXR is missing a few important features. The list you can see here. Some of these are in experimental and draft state. So eventually, some of these will make it into the WebXR spec. Right. But there are things that probably will never make it into the spec. So for example, raw feature points probably will never make it into the spec. Right. But with Babylon native, because we're not bound by a browser, we can do anything, right? So we have direct access to the underlying platform APIs. And thus, we don't have to wait for these features to be defined or implemented in a browser before we can use it. Okay. So here's a list of things that we do currently support. And this list is growing as we experiment and implement things. So for example, you see in this sort of a video playing, this is a Power Apps thing using Babylon native, Babylon React Native specifically. You see plane detection, you see hit testing with measurements, and the very short video is of non-planar geometry on iOS, and it's also experimental on HoloLens. We also support anchors, raw feature points, image tracking, which I'll show in a second, eye tracking, which is experimental on HoloLens, as well as frame capture with the camera feed. There is a camera feed experimental draft spec for WebXR, but it's not quite ready yet. But we can do this now. All right, so let's try and do this in a real demo. Let's see, I'm gonna switch over. Okay. So here, this is a sort of a bare bones Babylon React Native app right now. All I have is a box being rendered, and you can see Ronan is sort of moving the cube around. And so what I'm going to show is that I'm going to copy the same code that you saw in the playground. Oh yeah, I forgot to mention, what Ronan is running on is an iOS app. So this is not Android anymore. This is just iOS, but it's an app. It's not a web view. It's not a browser. It's just a pure app. So I'm going to paste this here. And again, it's the same exact function that you were seeing in the playground. The only difference is we have to hook it up to React Native. So I'm going to comment out the code for the box. And I'm going to put in just a little bit of code to sort of bind it with React Native. Now, what you'll see here is that the second I save, it's going to almost instantly change. There's no compile step. There's nothing. It just works, right? Oh, it's a little checking issue here. Try this one. Oh, you got it. OK. And remember, this is using the underlying platform API. So the tracking is not something we're implementing. This is Apple's implementation. Uh-oh. OK, double click. Okay, well, anyways, you get the point. The idea here is that the app shares the same code as the Playground app on the web. So you can take that web code, bring it into your native application, and it will run the same. It renders exactly the same. And that's how we were able to do this cross-platform write once and kind of run it anywhere. Sure, question? Can you repeat that question? Model viewer? So the Three.js one? Sorry, so the question is, can you use model viewer with this? The integration here is specifically to Babylon.js because we actually hook into the Babylon.js engine at the engine level. It's not hooked into it sort of generically. It's actually currently specific to Babylon.js. So it will be possible to use existing components to maybe hook into Three.js, but it's currently not written that way. It's intended to be for Babylon.js only. OK, so I guess the demo has crashed, but we will keep going here. But this is close to the end here. OK, so in this presentation, Ron and I have talked about sort of the Babylon platform, Babylon.js, Babylon Native, and Babylon React Native, as well as how XR plays into each one of these. Our projects are all open source. You can find them all on GitHub. And it's free for anyone to use. If you want to find out more, please click on these links that you see here. We also have a community forum where the core team pretty quickly answers questions, as well as documentation on many of the topics we presented today, and as well as the 2 Twitter handles you can use to contact us directly. So thank you. Thank you for coming. If you have any questions now, we can take some more questions. Oh, yes.
Let's wait for the microphone. I think it's good for the recording, yes.
So you'd mentioned support, obviously, for React. Are you going to be doing anything with Flutter? Or is it really, for all intents and purposes, just a monolithic choice to go the Facebook route?
The platform is written in a way that, like I said before, to be really flexible. Currently, we only have React Native because we have partners that are using React Native to do things. But Flutter, in theory, can be done. We just don't have anybody doing it. And it's an open source project, so we welcome other people to sort of make contributions to the project to integrate with other UI frameworks.
Thank you.
Right. Any other questions?
Do you have any? Thank you for the presentation. It's great. What is the? Let's compare the image recognition on this Babylon 5. How is the speed compared to other image recognition? Let's say AR Foundation or SAPAR. Do you know the speed?
I don't know what you're referring to specifically with the other two you're talking about, but we are hooked directly into the platform API. So the performance is, for the most part, whatever the platform API can do.
Should be.
Right. The only part that's perhaps will have a little bit of overhead is JavaScript. Right. So there's a JavaScript layer on top of that needs to run. And if you're in React Native, it's whatever React Native can provide in terms of JavaScript performance. So those two things added together is the performance you will get.
What about extended image recognition? When you move the phone out of the target and then you go back, is it going to be
I mean, if you, again, it's based on the platform, what the platform can provide. But if you move out of the screen, I think you're going to get an observable that says, hey, you've lost the tracker, right? And then you can deal with that however your app wants to deal with that. And then when the marker comes back into view and you want to track it, it again tells you, hey, you're now back on tracking, and then your app can react to that.
Thank you.
Yeah.
So in the example, we saw that there was a table fan kept. So was that an object already made, or you made that? And if it was a ready-made object, then how many objects are already there that we can use?
This specific model is a GLTF model. It's actually created by Patrick in the audience here.
Right here.
You can load, GLTF models. You can load OBJs, STLs, so like anything that Babylon can support to load, or you can procedurally create a model if you really wanted to, right? It's a 3D engine. You can do kind of what you want with that, and then as long as you place it in the right place based on the transformations that you're getting from the observable, you can do what you like there.
Babylon has an assets library where you can find many GLTF models and different models, not only GLTF, which you can use. They are also open source and are available. This one exists on our assets library.
Got it. So if I want to make a GLT model, then I need to use Babylon.js, or is there a different CAD for that?
So GLTF is the 3D format, right? It's a 3D format that similar to OBJ and STL, except it's it's a Chronos standard, and you can either use Blender, or you can use Autodesk 3ds Max. You can use other DCC creation tools to create that GLTF, and then you can bring that GLTF and load it into Babylon if you choose, right? But you don't have to. You can do other things as well. You had a question?
Here.
Since you guys have built Babylon native, there's a thought that you don't believe maybe as much in the browser becoming a first-class citizen in the future. So I'm just wanting to unpack, maybe if you're willing to unpack it a little bit further, if you feel like the browser has still life in it to support some of these 3D rendering, or because of other factors, native is really what's going to continue to be the first-class citizen in some of these devices, especially pressures from Google and Apple to keep it that way?
I think I'll answer it this way. We still believe the browser is the main thing, right? Eventually, the browsers will catch up, and they will have everything there, and you can just use WebXR, or other technologies, really, not just WebXR. But it will almost always be slightly behind the latest possible thing you could do in native, right? It would, because you have to standardize across all the different browsers, and you have to define specs that is across different browsers. It will almost always be slightly behind. And so native will allow you to sort of jump forward just slightly into the future before it makes it into the browser, right? And there are cases where, like, if you are already locked in with React Native, you don't really have a choice. You can't use a browser to do, if you already have an existing React Native app, for example, or an existing native app. It doesn't even have to be React Native, right? We actually have a documentation page where we sort of talk about the multiple different platforms, and we kind of go through a multiple choice question of what do you need, what do you want to do, and that will help you decide whether native is the appropriate solution for your scenario. Maybe I can point to that link a little bit later.
Awesome presentation. I guess one question is, how do you plan to make money? I mean, is this obviously, premium support, or,
We don't plan on it. Babylon will stay open source. I don't think there is a thought behind monetizing it. It's enabling web and 3D in the web.
Thank you.
Yeah. Internally, we use this
So yeah.
Yeah, we use this platform internally, right? So we have lots of internal products, as Ronan mentioned in his part, where we're using it for PowerPoint, for all these different applications. So they're effectively funding us, right? Because we're there. Right? We need to be here in order to support them, and we also then open it up for everyone else to use as well. So.
Very cool. Thank you.
Going back to the image recognition, do you know what is the smaller size on the recognition? So 1 centimeter?
The model size itself is
No, for the target.
so.
The tracker size, is that
The
what you mean?
tracker, yeah.
So how big it should be, if I understand correctly? How
how
small can it be? It's a good question. So we haven't experimented. We have experimented with much smaller ones. Probably half the size of this was working very well. We tracked objects kind of the size of the logo that you see here in the middle, but it needs to be a very specific object. So it has some form of feature detection on the image itself. So it cannot be something flat, or it needs to be a very recognizable image. And then as long as the underlying system recognizes the image, then WebXR will work with it. The underlying system, in that case Android, is the one that is detecting the image. We are just passing it to the web and are presenting the transformation and everything else.
You have to realize when you get closer, the image actually gets bigger, right? So it's kind of a relative size based on how close you are to the actual tracker.
If you see the QR on the screen, if you would try it, it would work. So you could project an image and a model on this screen as well, even with a bit of a smaller QR code. That worked, and we tried it.
Other questions? All right. Thank you very much.
Thank you so much.